Science, first 9 weeks, review. Safety. Always be safe. We use aprons to protect our clothes. We use gloves to protect our hands. We use goggles to protect our eyes. Forms of energy. Mechanical energy, the energy of motion, something moving, spinning, turning, sliding, something moving. Light energy coming from a light source, maybe like a light bulb giving off energy in a circuit, light energy. Thermal energy coming from heat. Maybe it's coming from the top of your stove. Giving off heat from a source, thermal energy. Electrical energy coming from electricity. Maybe thinking about the outlets in the wall. Maybe you're thinking about your iPod or your iDevice and how it has to be plugged into the outlet to get electricity. Sound energy. Maybe it's coming from a buzzer or something connected to a circuit. Buzzing off, giving a sound. Rapid changes to Earth's surface. Rapid means it happens very quickly. It's a fast change to the surface of the Earth. We have 3 main things that cause fast changes. It's either a volcanic eruption, an earthquake, or landslides. Volcanic eruptions, when the volcano spews out all the molten lava and magma, it adds new surface to the Earth. It breaks down, it destroys, burns anything in its path, and it's changing the Earth's surface quickly, rapidly. Earthquakes. Earthquakes normally happen because of the tectonic plates and how they are shifting and changing and bumping into each other. Sometimes earthquakes move away from each other. Sometimes the earthquakes move towards each other. There's different ways of earthquakes, but no matter what, the earthquakes happen quickly, fastly, suddenly. Sudden changes to the earth. And landslides. Sometimes landslides happen after a lot of rain and the earth can no longer, all the soil on the side of a hill can no longer stay on the side of the hill, and so it will all of a sudden start to slide down. It forms a fast change to the earth's surface. Physical characteristics of the environments that support the population and they support the communities. First, we learned about organisms. An organism is either a plant or an animal. All organisms have to have basic needs, and they get these needs from their environment, the area that they live in. The organisms need food, they need water, many of them need shelter, and everybody likes a little space for themselves. The population are all of the same kind of organism, like all of the deer. That would be the deer population. And as long as the deer population have all their needs met, if they have food and they have water and shelter and space, the deer population does just fine. The community would be all of the animals or all of the plants in that area. And they all interact and work together to survive or to help out each other. Changes occur in the states of matter. Change usually occurs by one of 2 things. We can either heat things up or we can cool things off. And when this happens, we have changes to the states of matter. So our solid, if we heat it up, the solid might melt into a liquid. If our liquid gets heated up, it might turn into a gas. On the other hand, we do have some liquids that when we cool them down, such as water, we put our liquid water into the refrigerator and cool it down, it can become a solid again. And then we also can get our gas And if we cool these gases enough, the gas can turn back into a liquid. And usually that happens up in the clouds and falls back to the earth as rain. Changes in the states of matter. They happen by two reasons: by heating or by cooling. We learned a lot about circuits. Most circuits start with some type of energy source. From the energy source we can connect other devices like a light bulb. We can also connect like a buzzer. And maybe other devices too. But the circuit has to be complete, has to completely connect, has to completely close before the electricity can flow and the light can come on or the buzzer can sound. If something interrupts the flow of electricity, if the wire disconnects or breaks, if the filament in the light bulb burns out, if the wire by the buzzer disconnects, if the wire next to the energy disconnects, if anything happens to this circuit, then the whole thing stops working. It must stay completely connected, completely touching for the energy to actually flow. Properties of soil. We tested the main property of soil was the soil's ability to retain water. That's what we want to look at first. Retain water. Retain the water means you are keeping the water in the soil. So for our soil like sand, we tested sand. We added in maybe 50 milliliters of water. Here's the example. The 50 milliliters of water goes in to the soil. Here's our sand all in the cup. Some of the water comes out. Whatever water comes out, this is the water that was collected. So when it reports to you that says 40 milliliters was collected from the sand, now we have a choice. Is this what it wants to know? How much was collected? Or did it want to know how much was retained? So you're going to have to read questions like this very carefully. If it says how much is collected, then the answer is 40 milliliters, and that was collected. But if you didn't have to figure this, then that may not be the question they're asking. They may be asking how much was retained, because that number is not here. The water went in, the water came out, so how much water stayed? You just subtract the 50 milliliters minus the 40 milliliters. 10 milliliters of water was retained. So read carefully. For the properties of soil, we also looked at some other things about the soil. It needs to support the plant growth. Certain plants, like different kinds of soil, supports plants. Most of the soil that supports the plants tends to have nutrients in it. Vitamins, minerals, something in it that really help the plants grow. We talked about life cycles. No matter what your life cycle, you do go through a series of orderly changes. So maybe a frog starts off as the egg. From the egg he comes into the tadpole. From the tadpole he becomes a froglet. He's got some legs. His tail might be shrinking. His body's starting to change. And then finally he becomes the adult frog. And Mr. Haas is not so good at drawing adult frogs, but you get the idea. Basic life cycle: egg, tadpole, froglet, adult. Animals are not the only ones that go through orderly changes in their life cycle, such as plants also. Many plants start off as a seed. The seed gets planted and watered, it gets some sun's energy, and starts to sprout under the ground. We may not even see this happening, but the seed begins to sprout. From then, now the seed begins to grow even taller above the ground. Maybe even a little leaf starts to appear. This is called a seedling. And then after a seedling, it becomes later the seed really turns into more roots underground, and the plant has gotten even bigger, thicker, maybe some branches, leaves, flowers. It depends on what we were growing. But no matter what this is the adult plant. And then it goes back and starts over again. It doesn't matter if it's the life cycle of an animal or the life cycle of a plant, they have similar things in common. The adults lay the eggs for the animals. The adults create the seeds for the plants. Mass. Mass is the amount of material in an object. Material. To find mass, we use the triple beam balance. We place the unknown object on the triple beam balance, and then we move the sliders. We move the 100 slider first, and then we move the 10 slider, and then we move the very front one on the units, and the 10th does. Then we put all those numbers together. The 100 says 200 grams, the 10 says 50 grams, and the front one says 5 and 4/10 grams. So the unknown object has a mass of 255 and 4/10 grams. We learned that mass usually stays the same unless you take some of the stuff away or you put some more stuff on it. If not, mass should stay. It doesn't matter if we mass the Coke can while the can is, after we drank the can is empty, but while the can is there, or if we mass the Coke can after we squish it, after it's empty also, the mass should be the same, as long as it was empty before we massed it the first time. So we can change the shape, we can change the size, we can crush it, we can tear it, but as long as all of the stuff is still there, the mass stays the same. The only time the mass would change is if we took some of it away. Parallel circuits. Just like circuits earlier, parallel circuits work really nicely because instead of like the series circuit, where everything was running one after another in a series, always connected. In the series circuit, everything lights up, but if one thing breaks or one thing comes disconnected, all of the items stop lighting up because they're in a series, one after another. But in the parallel circuit, this one can be better because we can go from the energy source to a light bulb, back to the energy source, and we can leave the same energy source to a different light bulb, back to the energy source, and now we have parallel circuits. The circuit that this light bulb is on is not connected with this one. So if this one burns out, this one can stay lit. This is probably the best feature about the parallel circuit, where the series circuit is a major weakness for the series circuit. Like some of your Christmas lights. One bulb falls out, they all stop working. But in the parallel, one falls out, one gets cut, one gets damaged, all the rest can stay working. You can have more than just 2 or 3 as long as you keep coming off of your energy source with totally separate wires. So this light bulb and that light bulb can both be shining, and this one's broken for some reason. They don't connect to each other, so they don't impact each other. Resources. There's 3 main types of resources. We have renewable, we have non-renewable, and then we have alternative. Renewable resources are very special because they all go around and around and around in cycles. Pretty much everything in this category cycles. And I remember it by WASP, W-A-S-P, water, air, animals,